Have you ever noticed how an advanced AI can, write a poem in a heartbeat, but then it just grinds to a halt on a tricky math problem? Well, we're going to dive into a brand new method that could seriously speed up how AI thinks. We're talking 5 times faster without making it any less smart. Let's get into it. It's this weird thing, right? You ask it for a fact, and boom, you get an answer instantly. But then you ask it to reason its way through a complicated, multi-step problem, and you can almost hear the gears grinding. Now, this isn't because the AI is dumb. It's all about how it's been taught to think. And yeah, that gets us right to the heart of the problem, the huge computational cost of deep thinking. When an AI has to solve something really complex, it can't just look up the answer in a book. It actually has to explore. And this is really the key difference. A simple task for an AI is kind of like recalling a memory, but a complex task, that forces it to generate and check a massive number of possible routes to find the right solution. It's not just about knowing, it's about discovering. So the standard way they do this is called tree search. And the best way to picture it is this. Imagine our AI is a hiker in a giant forest trying to find the best way out. To be absolutely certain it finds the best route, it sends a scout down every single path and fork it comes across. Right, so the thing to get here is that this method is exhaustive. At every single step of a problem, the AI comes up with multiple possible next steps, and this creates this enormous branching tree of possibilities. It's powerful, for sure, and it usually gets the right answer, but you can probably guess the downside. It's just incredibly wasteful. Our hiker is sending scouts down obvious dead ends and simple, straight paths with the same energy it uses for the really tricky intersections. This constant, relentless branching is exactly what makes complex AI reasoning so slow and so expensive. But what if there was a smarter way? What if our hiker could learn to just trust their gut on the easy parts and save the scouts for when they're actually needed? And that is the core idea behind a new framework called chain entry. The creator of this method, Xinzhe Li, really nails it here. It's an adaptive system. So instead of blindly branching out every single time, it intelligently decides when branching is actually worth it. It's about adding a layer of judgment to the whole process. Okay, so let's put this side by side. The old way is just brute force, explore everything. The new chain and tree way is strategic. Our hiker now walks confidently down the main path, and only when they hit a genuinely confusing fork in the road do they stop and send out scouts. For all the easy, obvious parts, they just keep moving forward in a straight chain. This, of course, is the million-dollar question, isn't it? If the AI isn't exploring every single path, how does it know which steps are easy and which ones are so complex that they need that full exploration? Well, the answer is surprisingly clever. So what the chain-in-tree framework does is it brings in a new component, a super lightweight evaluation method that acts like a judge. These judges take a quick look at the situation and decide, do we just chain forward, or is it time to branch out? And there are 2 main ways they do this. Meet our 2 judges. The first one, called BNDP, is like an expert consultant. It's a separate, specialized AI that gives a quick professional opinion on whether the next step is tricky. The second one, BNSC, is more like polling the crowd. It asks the main AI for a few different ideas on where to go. If they all basically say the same thing, you're good to go. Let's dig into the expert judge first. This is also known as direct prompting. It's the simpler approach. You just have a little helper AI that scores the next potential step on how necessary it is to branch out. If the score is low, meaning the step is totally obvious, the AI just chains forward. If the score is high, it knows it's time to branch. It's super fast, super direct, and, as we'll see, incredibly effective. Now for the wisdom of the crowd judge, or self-consistency. This is cool. Here, the main AI generates, let's say, 5 possible next moves. A helper AI then groups those suggestions based on their meaning. If, say, 4 out of the 5 are all basically saying, do this one calculation next, then the model is clearly very confident, so it chains forward. But if the suggestions are all over the map, that's a sign of uncertainty, and it's time to branch out and explore those different ideas. So we've got this really clever idea and 2 smart ways to pull it off. But does it actually work? Well, the researchers threw it at some notoriously difficult math problems, and the results are honestly staggering. This is the headline number right here. That expert judge method, BNDP, consistently slashed the runtime and the number of expensive AI calls by 75 to 85%. I mean, that's not just a tweak, that is a total game changer. It turns a process that took hours into one that takes minutes. And this table really tells the whole story. Just look at the runtime for a standard tree search method on a math benchmark, 2.25 hours. Now look at chain and tree with the expert judge, just over half an hour. That's a 77% savings. And the best part? Look at the accuracy. It dropped by a single, totally negligible percentage point. You get a massive speed up for pretty much the exact same quality of answer. And on an even tougher math benchmark, the difference is even more wild. The old way took almost 12 hours to run. With chain and tree, it was just over 2 hours. I mean, that's the difference between a cool research project and a practical tool that people can actually use day to day. But here's the kicker, the thing that makes this expert judge method so special. The researchers proved, mathematically, that it can never be slower than the original method. In the absolute worst case scenario, it performs exactly the same. But in pretty much every real-world case, it's way, way faster. There's literally no downside to using it. So, what's the big picture here? What does all this mean for the future of AI? Because this isn't just about one clever trick. It really points to a much bigger shift in how we build and use these incredible models. When you boil it all down, what should we really take away from this breakthrough? It's about way more than just getting answers to math problems faster. There are 3 huge takeaways. First, the quality of that judge is everything. A smarter judge leads to smarter, more efficient reasoning, period. Second, this kind of efficiency helps democratize AI. A process that once needed 12 hours and a ton of expensive hardware might soon be able to run on a laptop in your home. And finally, this shows us a new way forward. We don't always have to build bigger and bigger models. Sometimes we just need to build models that can think more efficiently and focus their brain power where it truly matters. And that really leaves us with this final, exciting question. Think about the really complex stuff, like scientific discovery, or designing new medicines, or complex engineering. What incredible breakthroughs are just waiting for us right on the other side of an AI that can solve problems not just with brute force, but with focused, efficient intelligence?